you were taught by an idiot on the internet who sits here and makes a fool of himself on a daily basis. Hi, I'm Steve from 123D. Today we are going to be doing a video on turning a photographed image into a template to then generate a 3D model in Fusion 360. So this is a relatively simple process, and it alleviates the need for you to have a 3D scanner or whatever else. So we thought it would be quite interesting for you guys at home to see how this is very, very possible and very doable with nothing more than a mobile phone, a ruler. I have a very long ruler, and I've also brought down a set of digital calipers, just in case we need those. I propose to show two variations of this process. The first one will be to literally copy or try and copy an item. For that example, I'm just going to use a simple spanner. And I thought it would be quite a good idea to obviously replicate something else that may be a little bit more practical and functional in your daily use. So for this instance, I've got a little ESP32 dev board, which if you were going to use this in one of your projects, which a lot of people do, you can actually produce a 3D printed enclosure for said board. I will go over the process in as much detail as I can, but I don't want to bore you, so we should jump straight in. So first thing that you need to do is actually get an image of the part that you want to recreate. And my honest opinion for this is, if you can get an image as close to vertically down as possible, that will give you the best results. Making sure that I've got it as pretty much as square as I really can within the photograph. I should just snap that one. I'll move that to one side, and at the same time, when I've got the camera out, I'll do the board at the same time, although I will show two different processes. So I have two pictures, so now I just need to transfer those pictures from my phone onto the computer.
Eventually.
So here we are in Fusion 360. Now, for those of you who aren't familiar with Fusion 360, there are a number of different versions of it available. You can have personal use, educational, commercial, so on, so on, so on. If you opt for the personal use version, it is license free. It will cost you nothing. It will limit the certain functions that you have available to you, but for the purpose of this video, and I found pretty much everything 3D printing related, all of the parts that you need for those processes are included in the personal license. It will limit the number of models or files that you can work on at any given time. I think it's 10, but typically doesn't really cause many problems. If there's a file in there that I'm still wanting to keep and don't want to disband altogether, I can export it to a folder, delete it from Fusion, and then if I want to work on it again in the future, I can just literally upload it, import it back into Fusion and carry on working with it. So there is workarounds. Once you open Fusion 360, you should be presented with a screen very similar to this, albeit your view will look like that. So first things that I want to do, in the right top corner of the screen, I've got this little cube. So typically what I tend to do when importing an image into Fusion, I always want to have it top down in the same orientation that I took the photograph, for simplicity. So click top, and as you can see now, I've got a bird's eye view of the actual 3D planes. So I want to first of all insert a canvas. So on the little drop down, I've got this little box here, canvas. Click on that, and it's going to basically insert from my computer. So I go to downloads, the first one I want to insert, and it'll basically highlight. Now it's asking me where I want to put it. So I want to put it on this plane, which are that little yellow orangey colour box is highlighting. I hover over it, and as you can see, it changes to grey. Click on there, and now I have basically the option for some measurements. So I don't really need to do much here. I can scale it up a touch. I mean, I'm going to go back in here and do some actual measurements to scale portions of the picture up. So now I have an image. Now what I can do with the image is, if I right click on the little icony box over here, I've got a couple of options. So as you can see, I have clicked on the little arrow, so it opens that folder and it shows the image file in that folder. And if I right click on the folder, I have various options. So I can edit the canvas, I can calibrate, I can delete it, I can do a couple of other bits and pieces. What I need to do firstly is calibrate. So what calibrate is is basically I want to mark 2 points on this picture. So if I, for example, I want to mark that side to that side, and it's given me a measurement in there. Now, that measurement is in millimeters. So what I'm going to do is my steel rule, I am going to measure the physical part to get an overall measurement. My part is 52 millimeters. So all I'm going to do is type 52 in the box, click, done. So now I can do a couple of other things. As you can see here, it isn't quite square, so I can manipulate it and get it as close as possible. So all I'm going to do is I'm going to click move. If I right click on the media again and then go to edit canvas, I can basically shift it around. So I want to try and line it up as best as I can with the line and use the actual pointer here to change it. Now it's jumping in basically literations of 0.5 degrees, which is a little bit too much. So I'm going to just put in there minus 0.2. It's not quite enough, so I'll go a little bit more. So literally I've done minus 0.5, and that looks quite parallel now to my line. So I can click OK. Now I've basically now got an image that will allow me to create a sketch over this part. So I'll show you what we do next. So pretty much all we do now is we're going to create a sketch. So here, again, we want to create it on this plane. First thing we need to do is basically create a box, because what I'm trying to just demonstrate here is I want to make a little 3D printed enclosure for this particular board, because ultimately it's got a lot of connection points on it and I don't want them to short. Drop in the box like so. If I want to, I can then go around the box. If I highlight that edge, I've just clicked on the icon here at the top where you can see it's got a curved corner. So I hover my mouse over it and I can select that, and then holding down the shift key I can then select the other. It's defaulted to a 10mm radius on the corner, which is far too much. So if I drop that down to 5, that's still too much. So I'll go to 3, still too much. I think 2 is a very good match, so I shall do a 2mm radius on the corner, and then literally all I'm going to do is repeat that process, that on the remaining corners. So again, we know it's 2. So if I click to 2, all of them have now jumped to a 2mm radius. So next up, really what I need to do now is decide how deep I want this enclosure box to be. If I take my ruler again, looking at the board, I've got little pins on the back. I'm not too fussed about the pins, but I thought for this project, I will go, for argument's sake, I will make my enclosure 20mm deep. I'll come to the top right hand side of the screen again, and it's got a little button there with a big tick in it saying finish sketch. So I'm literally going to click finish sketch, and all I'm going to do now is basically highlight this part here that I've just roughed out. So I'll click on that and I can click extrude, and I want it to be 20mm. So I shall click 20mm in there and I will extrude it. So from here, it doesn't look like anything has happened, but if I then pan, you can see that I now have a box that is 20mm. What I can now do is if I click on that again, I can go on to modify and I can actually give it a shell command. So what shell does is basically hollows out the box. So if I stipulate what size I want the walls, I can basically shell it out and leave the walls and the base to a certain thickness. I will try 1mm first off to see how that looks. And to be honest, it looks pretty good. I will literally click OK. So now what I've done is I've basically made a box that has a 1mm perimeter all around it and the bottom as well. And that should work out very nicely for our actual printed part once we go through that process. So what I need to do now is, as you can see on the board picture that I've put in, we have got some holes in the board. Now it would be quite handy at this point to basically use those images to put some little pillars, standoffs in the bottom of the box so we can lift it off and obviously compensate for our pins that are sticking out the bottom. So again, to do this, literally go back onto your top view. I'll then click sketch again, and then I will basically want to create a sketch on this downward bottom plane again. So again, I've literally clicked on it, and then I'm going to use the circle tool and zoom in and just basically try and line up the circles as accurately as I possibly can. Now it does want to snap to certain areas, as you can see. So sometimes the closer you get in, the smaller the snap point gets to. And it's not critical at this point to get it actually bang on, because you can move this circle around once you're finished. I'll get this as close as. So I'm thinking 3.5 millimeters is pretty much where I need to be. So I'll click that, and I have now a circle that fits inside the image that we've uploaded in the actual model. So I'll repeat this on the other holes. So at that point, I could then mark sketch complete. And just for non-confusing matters, I will now make the actual image invisible, so it shows the points that we've got in the model. So all I'm going to do now is basically zoom in, holding the shift key again. I'm going to highlight each of these, and then all I want to do is I want to extrude those again. Oh, not with my phone. I'm just going to measure how long the pins are. So my pin's 10 millimeters long. So if I extrude those 10 millimeters, that should give us ample for what we actually need. And then what you see in this little drop down box, it's got operation join. In this instance, that's exactly what we want to do. We don't want to make it a separate part. We want it joined to the actual 3D model that we're creating. So I shall click OK. And as you can see, we now have some little pillars. So if we really want to, at this point, we can then go on top view again, and we can create another sketch plane. Now, if I want to do that, I'm going to literally click on that circle. So it's using the top of that circle we've just extruded as the actual point for the sketch. And all I'm going to do is in the center of that circle, I want a pilot hole. So I will go 2.5. 2.5 is a little bit big. I'll go 2 millimeters. So if you zoom in, it will automatically try and snap. So 2. Okay. Again, I'm just 2. And the last one, 2. And then I'm going to hit finish sketch again, zoom back out, and the same process as before. What I want to do is click extrude and then highlight the center, holding down the shift key again so I can do all of them in one go, like so. So if I go -8, it's going to take me 8 millimeters down into that column that we've just extruded at 10 millimeters. Plus we've got a millimeter at the bottom of the base, which is then 11 millimeters. So effectively, we've still got plenty enough material. And as you can see, it's defaultly changed this option to cut. So instead of adding material to the model, it's now taking material away, which is absolutely perfect. That's exactly what I want. So I shall click OK. And as you can see, I now have little holes. So I can now effectively screw my board down. So this part is pretty much done. So all I really need to do now is, if I'm going to print it, is I want to export it. So how do you do that, you might ask? Quite simple. I just go up to the little file icon here, and I shall click on export, and I will call this ESP. I might want to make tweaks to it until I've got the final version printed out and I'm happy with it. Then I'll mark it as test. Once I've got the final version, I will then name it enclosure or whatever. Currently, it's defaultly set to Autodesk Fusion archive file. That isn't the format that any 3D printer recognizes, so I'll click on the arrow drop down box and I have the option to export it as an OBJ or a STP or an STL. So I'm going to export it as an STL file. So I'll literally click STL. It's going to export this file straight to my downloads. Click export. Boom. Done. It is away. It is now in my downloads folder, ready to upload straight into my slicer. It is that simple. So what we're doing with the exported file, I will send it to print. I basically will print it off and we can then show the board sitting inside it, or if we need to make any tweaks or whatever else, but we'll show all of that process as well. So next, something a little bit different. Again, we've just used a spanner as an example. This could apply to anything. If you've got a plastic part, for instance, that a part's broken from, will be an ideal situation for using this scenario. So you basically want to replicate something that you already have that may need amending or altering, or it's broken, there's a piece missing, and you want to engineer that piece back in so it's complete again, so you can then go on and 3D print a new one. So we thought we'd show that with a spanner. So again, the process for this is exactly the same. So I'm going to click on the top-down view model. All I've done, by the way, is just opened up another tab at the top, so I've still got my original model in another tab. And again, I want to insert a canvas. It's going to ask me again. I want to insert this from my computer. I know it's in my downloads and it is the Media 1. So there you go. it is now there. And again, just for the reference of the video, I'm going to make it a little bit bigger so I can actually see it. I'm there, and I think I want to be about minus 2.5. So I'll try that. 2.5 is too much. 1's probably better, so I'll go -1. So yeah, unfortunately, I was 1 degree out of my squareness of my photography. Shocking. So yeah, once I've done that, I shall again just click OK, and that is that image there. Bosh, straight on my sketch plane. So all I need to do now is again start to create. Oh, and actually, I'm skipping ahead. Steve, slow down. On canvas, click on the arrow again, and then open up this little menu box here, and then I want to right click on that. So again, I need to find 2 reference points that I can accurately measure from and to. I'm going to pick this point here back to this point here, and I'm seeing that my spanner is overall 165 millimeters. The closer you get this, the more accurate everything will be going forward. So there's my first point to the widest point on the backside, and then I know that that was 165 millimeters. So I'll click in, done. So all I need to do now is actually start mapping out my sketch. I shall go with line. So I'll click on that, and I'll zoom in and basically start sketching the straight portions of my spanner. You can jump straight across, don't worry about it. I'll show you how to remove any lines that we don't actually want. Once we've finished, we'll do for my lines. Then obviously here we've got a bit of a curved portion. So if I go on this again, I can select different options. I mean, fit splines is probably the best one. So again, spline tool is quite handy. It'll allow you to put in multiple points, basically follow the profile of the actual part. Okay. So if I hit line, it takes me back to line mode, but now you can see that I've got all of these little bits and pieces joined up. So now I need to join this piece to this piece. So I'll click on spline again, and I will literally jump onto that. There we go. So now I've joined that up. I'll repeat the same process down this side. So again, just click on that spline tool, start off and snap on that dot, zoom in as much as possible, and just start sketching around here. And again, we're snapped out to that. So I'll click on my line tool again, and the final part, I have a couple of options here. I know that the end of the spanner is pretty much going to be a circle. So for ease, I will roughly guesstimate where I believe the center of that circle to be, and I will just drag out a circle like that. So then I'll go back to my spline tool and then literally follow from that end point, snap it into my point there. So I've joined that to the circle. Again, repeat the same process for the bottom here. Just trace around that outline. So now if I go over to trim tool and click on those little scissors, as you can see in there, it's given me the option. I can now cut that. I can cut that one, cut that one. I'm quite happy. That is not bad. So all I'll do now is I'll click finish sketch, and I shall go to extrude. And as you can see, it's highlighted the whole area. I will extrude it to 8 millimeters. There we go. So I'll turn off now the actual spanner image so we can see what we've got. So as you can see, we have a very, very loosely modelled spanner, basically produced from nothing more than a photograph. But again, just to really highlight how easy it is to take a photograph of something, provided you've got a ruler or a set of calipers, which you've not even used in this video, it is really, really simple to do. And it will produce results that are pretty accurate in my experience. But as I say, we will print out the enclosure so you can see how the little ESP32 fits in there. There's lots that you can do. My job here is just to inspire you. So what we will do next is we will print off both of the items that we've currently modelled, and we will show a comparison. So scale representation, how big is the printed part in comparison to the actual spanner? And we shall also print off the little enclosure that we've just modelled up for this little board. Let's go and find some filament. Okay, so we downloaded the prints, the STLs, I should say. We downloaded the STLs. Chris kindly then sliced them and sent them magically to the Century Carbon. Literally 30 minutes later, ladies and gentlemen, we have the finished printed part. The proof is in the pudding. This pudding may be yellow, like custard. Here is our spanner. So all I'm really interested in at this point is basically validating the size accuracy. from the photograph that we took to the manual measurement that I took to actual real life part. So all I'm going to do is basically pop those together, and as you can see from a photograph and a ruler, that is not bad in terms of tolerance. I'm not saying by any means that this would be down to a thou of a millimetre or anything like that. It's not machining CNC accuracy, but for a prototype 3D printed part, it is very, very acceptable. And the more time you spend on this, the more accurate you will actually get it. So again, just to show the simplicity of this process, it is very achievable very quickly and very easily. So next, let's see if our little board fits inside our little enclosure that we rough modelled out. So again, it is a perfectly snug fit. And just looking at it, I've got a couple of, if I was to actually remove a portion for the USB-C, so it pops through there, everything would line up in there absolutely perfectly. But because I haven't, and the port is literally just pushing this wall a little tiny bit, it has slightly moved my post holes off position. So again, just as a rough representation, I mean, that goes to show how tight and quick and easy you can get things done just by a simple photograph of a component or whatever to produce a housing or an enclosure for it. There is a lot of other options available. I mean, if you wanted to, you could go down the whole CAD route from scratch, which would involve measuring the board, all of the holes and all of that type of thing manually and creating a model from scratch. Or you can go through the photograph template option like I've shown here. It depends on what you're trying to achieve. If you want to just like roughly rough out a prototype part like I've done, then it is absolutely worthwhile. Again, shape complexity and whatever else, you might get something, for instance, I don't know, for argument's sake, we haven't got a case for our calipers, so we could photograph a set of calipers, we could again measure it, and then we could effectively model in CAD a case, so it'll hold in the same principle as the foam insert, so that would all be 3D printed, and then you could pop your calipers into it, store those away nicely. It will apply to a whole range of different things. And again, we will be producing more content along these lines going forward. So please don't forget to like, subscribe and share if you're not doing so already. Because if you're keen to take your 3D printing skills to the next level, this will be the place to do that. Going forward, we will be producing more in-depth videos into Fusion 360 CAD modeling for 3D printing applications. I will go over a few little caveats in the design process that you want to try and implement and get used to using. The fundamental skills to basically get started, start experimenting, because there's no better way in my mind to learn than to try yourself. Anyway, that is it. I am going to see you on the next one. And like I've said already, please do not forget to like, subscribe and share. Be sure to check out the link in the description to our website where you will find a whole range of different things from 3D printers, consumables, CNCs, lasers, 3D scanners, and a whole lot more. See you on the next one. Bye-bye for now.
As always, we aim to have the most competitive 3D printer prices on the market. If you see any of our printers being sold by a mainstream retailer for less, please drop us an email using the link in the description and we'll do our very best to beat their price. Also, if you're watching from outside the UK, check the description for links to our European 123 3D sister stores.